Well, hello, good afternoon. It's very nice to be here. I'm going to be talking to you a little bit about a ratio. As you know, I am the world's most famous detective, and there is a bit more detective work involved here. And I'm so successful. I'm sitting here with a nice glass of wine by my swimming pool, and I hope everything will. Ah, no! Oh, no, what is going on? Oh, help me! Oh, b- b- you will not believe this. I fell into the water. Help me. Okay, that is it. Here we are. We're going to talk about ratio. Things may get a little bit wet because I am covered in water. Okay. It says here that ratio is a little bit like fractions, and that is a very good way of thinking about it, or it is one good way of thinking about it. Let us count what we have here in this picture. We have 1, 2, 3, 4 red. So I'm going to write a little R for red and say that we have 4 red. And then we are going to count the blue. 1, 2, 3, 4, 5 with 1 in the middle. So of the blue, we have 5. And what is important is just to realize that there is a total here. The total number of shaded squares is 9. 9. Okay? So we have 4 red and 5 blue. And the way we show this in a ratio is just to write it slightly differently. So we usually write it like this. With a different color. So we write it like this. We have red and we have blue. And we have 4 red and 5 blue. And we put a colon there like that. And we read it 4 to 5. 4 to 5. It's a ratio of 4 to 5. Now, what is very important to realize is that the total of this is still 9. Okay. And one reason it is very like fractions is that we can multiply up. If you imagine we have equivalent fractions where you multiply the top and the bottom by the same. So we could have a ratio of 8 to 10. The total is 18. And that would be the same thing. We would have 8 red squares and 10 blue squares. And we have just multiplied each of these by 2. And that means we also have double the number of squares in total. So the total is doubled. Okay? So, and that works the other way as well. For example, if we have 80 squares, no, if we have 40 squares, that's not 40. If we have 40 squares that are red, that would be 40. And we would have 50 squares that are blue. And therefore, we would have the same kind of idea. It is a ratio of 40 to 50. And there are a total of 90 squares in total. We would never write a ratio like this because we want to get down to the simplest form, like the simplest form of a fraction. One other important thing to say about ratio and fractions is to point out that the fraction here, the fraction of red would be 4 out of 9. Okay, that's a fraction of red. The ratio is 4 to 5 because the fraction of blue is 5 to 9. And 4 plus 5 equals 9. So in total we have 9 squares shaded, and I've forgotten what I was going to say. It's because my ears are wet because I fell in the water. But we have 4 ninths and 5 ninths, and that makes 9 ninths. In ratio terms, we are talking about a ratio of 4 to 5. Okay, we are going to look at our recipe and see how a ratio can help us. Okay, so imagine you are making a lovely cake for 4 of your friends, and the recipe tells you of all the ingredients you need. For every 3 measures of flour, you need 2 measures of sugar. That means the ratio of flour to sugar is 3 to 2. We could ask ourselves, can we simplify this at all? And the answer is no. It is 3 to 2. We cannot divide by anything to make it more simple. So the ratio is 3 to 2. So that could be a very small cake made with 3 grams of flour and 2 grams of sugar. It would be a cake the size of a teaspoon. It is not really worth having. But it might be more likely 300 grams of flour and 200 grams of sugar. Your cake would be 500 grams of these ingredients, okay? It could also be, remember, as long as we divide by the same number, it doesn't matter. So we could have divided by 2 is 150 grams of flour and 100 grams of sugar. As long as the ratio stays the same, it is always 3 to 2. You can say here with the flour here that it is 3 lots of 50 and 2 lots of 50 grams. Okay? You can think of it how you want. Now, the next problem is what happens if more people turn up? Okay? So let us say that this is our base cake for 4 people. Okay? It is for 4 people. What about if 6 people turn up? Oops, we need a bigger cake. So for 6 people, we will need to change the ingredients for the cake, and we will do it like this. So, what is happening? Why are you not helping me? That is very strange. Okay, let's try one more time. 6 people. Okay, so the question is, how much bigger must the cake be? And the answer is this. Well, we need to look at actually another ratio. We need to find the ratio of 6 people to 4 people. And in fact, if we just do 6, oops, I'm so sorry. What has happened here? Okay. If we just do 6 divided by 4, that equals 1.5. Okay. You can even think of this as a ratio of 1 to 1.5 or 1.5 to 1. It means we have to multiply each of these things by 1.5 to get to the amount we need. So 300 by 1.5 is 450. And 200 times 1.5 is 300. And this will be the number, will be the amount we need for 6 people. I hope that helps. I'm going away to dry my hair. I'm freezing cold and very wet. Goodbye.